Hi, I paid $1.35 for 241 company websites. The AI picked the scraping tool, ran the entire job, gave me a clean looking spreadsheet. I checked 12 results manually, 2 were accurate, 2 out of 12. Versus when I got involved and I ensured that I picked up the actor. That's not a prompting problem. That's not a platform problem. That's a tool selection problem, and nobody talks about it. Today, I'm going to show you exactly what happened, what I should have done, and how you, whether you're a founder, a builder, or someone just getting into automation, can avoid this completely. I'm Mantra from An Automate, and let's get into it. So, this is part one of a two-part series where in this video, which is part one, I will show you the goal, results of the experiment with screenshots, with what happened when I let AI choose the actor versus when I got involved. And part two will be where I actually show you a running demo of both Apify, how to go about searching the right actor for the task, and how to plug it into make.com. So here's what I was actually trying to do. I had a list of 241 Indian incubators and accelerators. I needed the official website for each one. Simple enough, right? Bulk task, classic use case for web scraping. I was going to use Apify, a scraping platform which is also a marketplace of pre-built scraping tools called actors. Now, before I even get into what went wrong, I want to flag something. This exact workflow applies to a lot more than incubators. It applies to sales leads, vendor directories, partner lists, investor databases. So, anytime you need to enrich a bulk list with website identification data, this is the same problem. But let me tell you what happened to me first. There are two main ways to run a scraping actor. Option 1, use an IDE. In my case, Anti-Gravity, which is built using Claude Sonnet model, the one that I used. You give it natural language instructions. It figures out which API actor to use, runs the task, and scripts the output to a file. The API key lives in your .env file or your environment file. After the first time you set it up, the IDE just reads it automatically. You don't have to think about it again. Option 2, make.com or N10. You build a visual scenario, you connect your API account once. That's your one time connection setup. And from that point, every scenario you build uses that connection. Visual, drag and drop, and no code. You have to provide the actor yourself. Now, both platforms are legitimate, both have their place. The difference isn't really about capability, it's about control and specifically who chooses the actor. In the IDE, if you just say, let me find the websites for these companies, the AI will pick the actor for you. It will search Apify, find something that looks appropriate to it, and run it. That's exactly what I did, and that's where it went wrong. Now, I gave anti gravity cost constraints. I basically said, find me company websites, keep it cheap. It selected an actor within those parameters called Google Search Scraper. No questions asked, just ran it to 41 rows. I got back a spreadsheet. It looked complete, websites populated for most rows. I started checking manual row by row. Out of the first 12 I checked, 2 were correct, 2. That's it, the 16%. I stopped checking after that because here's the thing, if you're getting 16% accuracy, there's no point in bulk processing the rest. You spend more time fixing the data than if you just done it manually. So $1.35 for pure garbage. Here is the actual output. You can see the website column looks populated, looks fine, but when you click through, wrong pages, wrong companies, some pointing to ynos.in startup profiles instead of the actual incubator website. The AI didn't lie to me. It just picked the wrong tool, and the wrong tool gave me confidently the wrong data. And this is what we will tackle as to how you can find the right actor for your task, and irrespective of your platform you should be able to do your job correctly. So why did AI pick up a bad actor, and what does bad even mean here? Here's what I discovered when I actually went to Apify and looked myself. Some actors have hidden dependencies that are buried in the description. One actor I looked at, and this is a real example, only returns a company website if Google's right hand business info box exists for that company. You know that panel that appears on the right hand side of Google search results with the company's details, address, phone number, etc. If that box does not exist for the company you're searching, then the actor returns nothing. No result, no error, just empty, because that's how the actor is designed. Now, for Indian incubators or many smaller accelerators, university run, many of them are government programs or university cells or niche organizations that, and for that Google box may often not just exist. So the actor just silently, in such cases, returns nothing or returns a bad URL. Now, I know this because I experimented with this too, so I'm able to tell you. This is written in the actor description. It is there and you must read it. The AI didn't read it carefully enough. And I didn't read it at all because I let AI handle the selection. And this is where the mismatch happened. That's the hidden variable. It's not just about which actor sounds right, it's about whether the actor's data requirements match your actual data. So choose your actor scraping tool thoughtfully. Now, look at the AP5 store screenshot. This is the AP5 store where I searched for find company websites. Now, it gave me 1,274 actors. They all sound familiar. They all claim to do roughly the same thing, but they work completely different under the hood. Different data sources, different accuracy, different pricing, different configuration requirements. The AI picked one. I should have picked one myself. That is the entire lesson of this video. So I went back to AP5, searched myself this time, found an actor called Domain by API Oracle. I didn't just run it. I tested it first, 5 rows manually, one by one. 4 out of 5 came back accurate, 80%. Same platform, same goal, same data, different actor chosen by me. That jump from 16% to 80% accuracy is not magic. It's just the difference between letting the AI make a critical tool selection for you versus spending 20 minutes reading the descriptions and testing yourself. This is what human in the loop actually means in a practical context, not just reviewing outputs, staying in the decision loop for the parts that matter most, like which tool you are trusting with your data. Here's the actor page, $19 per thousand results. Rating 4.1, 645 users. It's community maintained and validated. The README, look at it, it's on the left hand side, which has then inputs, pricing, API reviews, issues all mentioned. And I will suggest that you critically read these portions before you even experiment with a few. It tells you exactly what inputs it needs, what it returns, and what it can't handle. This is the document you read before you run anything at scale. All right, so here's what I now do every time. I need to pick a scraping actor, whether I'm building in make.com or running through an IDE. This is the process. Now, of course, you can also choose N10, you can also choose Zapier. Step one, read the full description, not the headline, the full description. You're looking for hidden dependencies. Does it need a specific data format? Does it require the company to have a Google business listing? Does it only work with certain geographies? This is where the traps live. Low stars with low user count means nobody's tried it enough to know if it works. High stars with high user count is your confidence signal. Look specifically for reviews that mention accuracy, not just speed or ease of use. In fact, when you will be running this or even testing it, AP5 will ask you to leave a feedback or a review. Do fill them up, because many of them are necessary for those who will come to this actor and who will be needing it or will take a decision. For some also it's important because those who create these actors will also review your feedback and maybe improve upon it. Then step 3, test 5 to 7 rows or maybe a couple of more here and there rows manually before any bulk run. This is non negotiable. Pick actual rows from your data set, run them individually, check every result by hand, verify the output matches what you expected, not just what it returns something, but that it returned the right thing. If 4 out of 5 come back correct, you have enough confidence to scale. If 2 out of 5 come back correct, stop right there and try a different actor. But suppose say if you have a benchmark that all 100% have to be correct, then maybe this is not the right actor for you. I chose 80%, but that is not what you need to accept. This should definitely take around 20 minutes or so, but it will save you hours of data cleaning later. Also, compare pricing across similar actors. Similar actors doing the same job can differ by 5x in cost per thousand results. Always do the math for your volume before committing. $19 per thousand might sound cheap until you're running 50,000 rows. And accuracy matters more than cost. An actor that costs 3x more but gives you 80% accuracy is cheaper in real terms than a cheap actor with 16% accuracy, because you will spend time and money fixing bad data. Also, when you run at scale, it is just not $19 for 1000 results. You also need to have the basic API dashboard subscription. So take all prices into consideration. Step 5, check the configuration requirements upfront. Input format, output schema, API key setup. The API key setup is on the left hand side. These vary by actor. Mismatches here cause silent failures. The actor runs, returns nothing, and you won't even immediately know why. So, read the input tab on the actor page very clearly. Make sure your data matches what it expects. Run through these 5 steps. I promise that it takes around 20 minutes or so, and it is the entire difference between 16% and 80% accuracy. Now, a quick note on something nobody explains clearly: how API key setup actually works on both platforms. I will show in part 2 where I will be giving you the demo. But it is like this: in an IDE like Anti Gravity or Cloud Code, your API key lives in a dot environment file on your local machine. You set it up once, first time IDE will check your file structure and try to locate it. Else, will ask you to provide it. From that point, every time the IDE runs an API task, it reads the key from that file automatically. You never enter it again. I'm not going into an entire few minutes on how to set up IDEs. For that, maybe you can take a look at other videos, but I will show you from where to get the API key and at least plug it in a make.com scenario, or you can replace that by n10. In make.com also, you create a connection once in the platform's connection settings. You paste in your API key, name the connection, save it. From that point, every scenario you can build by using that connection. Every team member on the account can also use it. It's stored securely in the platform, no file to manage. Both approaches are clean. The pain is only on day one, setting it up for the first time. After that, it's invisible. Trust me, even for no code people, it is not at all difficult. And most platforms nowadays across different kinds of tools are having API, and picking them up and copy pasting it is relatively simple. So, which platform should you use? Here's my honest take: neither is universally better. It depends on two things: what you're trying to do and how you're comfortable working. Stopping a run now midway. Okay, if that's your parameter, then make.com wins clearly. You can pause or stop a scenario at any time. In an IDE, once a task starts executing, especially with API running on its own servers, it's very hard to stop. I've had to manually abort runs from the API dashboard itself because the IDE could stop what it had already triggered. And yes, it will then burn through your money. I have experimented quite a bit, so I know that even with a lot of stringent guardrails, sometimes these things can happen. So I would personally, maybe a lot of people will show that you can do large scale bulk runs using IDEs, and they can handle this. But if you have set up the right directive files, the markdown files that give the IDE agent its guardrails, the right actor choice, the right output format, with that preparation, an IDE can run very large batches. Make.com has scenario operation limits depending upon your plan, but on paid plans, it can handle very large executions. Now, API key is the setup, and neither is harder than the other. Comfort level. This is the real deciding factor for most people. If you're comfortable with natural language and don't mind a code environment, then use the IDE. If you prefer visual drag and drop and want to see every module clearly, then Make.com or N8N or Zapier would be preferable. Both are legitimate professional tools. My conclusion, don't choose the platform until you have chosen the actor and whatever you're comfortable with, say technically or non technically in the case of IDEs also. The actor is the thing that determines your accuracy, the platform is just how you trigger it. Now, I said at the beginning of this video to wait till the very end, and this is how the make.com scenario will look like. I will show it to you in part 2 as to what it does. But basically, Google Sheets will take all the list of the websites list. Suppose, say, I will put all 241 in one row, in one column. Then AP5 will run the task and will search for all those 241 companies. Then it'll get the data set items, or in short it'll fetch the data. It'll split and iterate all the data and ensure that it goes into the right column in my Google Sheet, and that same tab gets updated. So here's what I want you to take away from this. The platform doesn't save you, the actor does. Before you run any bulk scraping task, take about 20 or so valuable minutes or so and use the framework suggested into zero in your actor, then commit. If you found this useful, please subscribe. This channel is about real client work, real tools, real results, no theory, no hype. One question for you in the comments: which scraping use case are you working on? Company websites, social profiles, product data, tender listings. Do tell me. I read every comment and I build content based on what you actually need. I'm Mantra from An Automate. Build, scale, optimize, and see you in the next one.